Hey everyone, I hope you all are doing well. Thank you very much for joining us for the Selenium Community Live episode 2. This time we have David Burns with us. A brief introduction about David, although he needs no introduction, but still. David, first of all, thank you very much for joining us. David is a project leadership committee member at Selenium, and he's the chair at the W3C browser testing and tools work group. David also heads the open source and developer advocacy at Browser Stack. And today, with the community, David would like to talk about all about browser engines, and why they are not equal. And we would be then taking your questions at the end of the talk. So David would be talking for around 35 to 40 minutes, and we will then be taking your questions at the end of his presentation. So, a warm welcome to all of you at our Selenium Community Live episode. Thank you so much, David. Over to you.
Thank you, Pallavi. What a warm welcome, and thank you very much. So hopefully today, by the end of it, everyone would have learned something about browsers, how browser engines generally work. So this is a high-level overview. One of the first things that I'm going to put out there, because this was some of the comments that I received the last time I did this talk, was, David, you're only doing this because you work for a company that puts real browsers in the cloud for everyone. That's not true. So I'll be going through the reasons why, but if you're here to start with there, let's get that out of your mind. Let's start from somewhere fresh. Let's hopefully learn from each other and then go from there. And at the end, I'm sure there'll be some questions, and we can go through it all. Yeah, as Pallavi says, I'm David. I head up developer advocacy at Browser Stack, and I run the open source program office. Do stuff with Selenium, do stuff with browsers. So I'm generally around this industry quite a lot, and I've been doing Selenium since 2008, so a very long time. And I love it because the community is amazing. You are all like it. Everyone here who kind of is in the community, you are the reason why I like to do it, and why I still come back and support the project after many, many years. So I've got a high-level agenda that I'll be going through everything. So I'll be talking about specifications. The specifications part is going to be the key part here. The idea of what levels of real user testing there are. And so not everything is equal. And when you know that not everything is equal, this can have interesting implications on the type of framework that you use for your testing. Again, I'm not telling you what to use, but at least if you have the knowledge, you can make informed decisions. The idea of headless versus headful testing, technicalities and the examples around that. I'll be talking about browser engines versus real browsers. Again, technicalities and examples. And then real mobile browsers versus simulated browsers. And how that can be very different in certain circumstances. Again, this is not to tell you that you should be using one or the other. The idea is that you have at least the knowledge and you understand the risks. And when you understand the risks and you have the knowledge, you can go do amazing things. And then at the end, I'm going to answer as many questions as possible. If you have any other questions afterwards, feel free to kind of just message me. I don't generally go on Twitter anymore, so you can find me on Blue Sky. I'm at automatedtester.co.uk. Or you can find me on LinkedIn, or you can find me generally anywhere else that I'm around. I'm on a number of communities, so I like to answer questions. I want to support all of you where I can, so do ask them as we go through. Cool. So let's get started with specifications. So as Pallavi said, I'm the chair of the W3C's working group around browser testing and tools. So what that working group does is it works on three main specifications. The first one being WebDriver Classic or WebDriver HTTP, which is the general WebDriver that you use every day. The next specification is WebDriver BiDi. There's been a number of talks from my colleague Pooja Jajani, from other Selenium committers, from Googlers, from Mozillians. And the idea there is that we move the kind of transport protocol over to a bidirectional one. And by moving it to a bidirectional one, it allows us to create event-driven APIs that we can do a lot more. And so you can see some of that stuff with the way Selenium does network interceptions, DOM mutations, things like that. And we can do that. The other one, and this is a recent one, is one called AT driver. And this is a specification built on top of WebDriver BiDi that allows us to drive accessibility tools. So that's what the AT stands for, accessibility tools. The main one being screen readers. So that if you wanted to drive a screen reader and make sure that what experience you're getting between Windows and Linux is the same, this is how you would do it. And the main reason for that one is that each browser does their own, or not each browser, each window manager does their own way of doing it and generally go, I'm going to do it the right way. So when it comes to browsers, whenever they tend to look at accessibility, they have to try figure out 3 different ways of doing it because there are 3 main operating systems or window managers, which is your Mac OS, your Windows, and your Linux. And so it can get a bit crazy, and we can get really, really confused very quickly, which is why, for the most part, specifications generally create a level playing ground for all products to use. And once you have a level playing ground, at least for the base information or the base ways of driving things, then you can go and do other interesting things, right? So once ECMAScripts kind of standardized a lot more, we were able to start seeing better and simpler bits of code, and we didn't need to rely on kind of things like jQuery, but we could then build front-end frameworks, and we have React and things like that, where they don't need to worry about how do we find elements on the page anymore, because the underlying tools are there, and now we have difference of opinions between Vue, React, and so on. And one of the key things when we're doing specifications is this RFC 2119. And it's the underlying specification of all specifications. In the same way that once you get the baseline sorted, you can build everything on top, you need to still have that baseline. And for the most part, it's around the wording that needs to be used in specifications. The idea here is that words, if you want something to do something, it must do it or it must not do it. If there's wording like should or should not, then that's kind of recommended, right? We suggest you do it. And the difference between a must and a should can create bugs. And this is, and this is where interesting problems come up in our industry, because people will go, oh, it should do this, it should do that, or should not do that. And one browser will interpret should as a must. Another browser will go, it should, but actually it's a lot of work, so I don't feel like doing it, so I'm not going to do it. It said should. And that gray area is where bugs live. I'm sure we've all worked with product managers and kind of looked at product briefs, and you look at it and you go, oh, it should do this. And it's like, okay, cool. But must it do it? Because if it doesn't do it, do I raise a bug? Do I care about these things? Do you, and so forth. And this is where words start to matter. I know that in the testing space, people get really worked up about certain words versus a test versus a check, for example, right? To me, at the end of the day, they're still finding out if the scenario does what it should do or not. In this case, it can create different meanings by different people. And this is where diversity really matters, because the way I interpret something as a English native speaker versus someone who's English as a second language, even though their English might be fantastic, becomes really, really important. Sorry, I've just noticed my camera has decided to shut off. Let me sort that for a second. Oh. Settings, camera, USB live. There we go. Sorry. Let me go back. So we have this. And then when we start to interpret these bugs, things like that, then we get interesting bugs. And I've said for a very long time, while I was at Mozilla, that we should always test where our users are, right? And that includes using the browsers that they are using. Now, I appreciate this is not going to be easy in every circumstance, and I'm hoping that at least if I give you the tools, the ways to build on top of that, that you can actually care about it in a meaningful way. And so what do I mean by real user testing, right? Real user testing is also is trying to get our tests to act like a real user when we are doing end-to-end scenarios. This is really important for kind of end-to-end scenarios. It's less of an issue if you're doing kind of API testing or integration testing. For the most part, everything should work. Again, because there are standards that have good language in them and that allow us to build off it, right? And what do I mean by real user testing, right? Sometimes the way we interpret a click, for example, or a touch on a screen can vary depending on the way we execute it. And by that I mean, like, the way Selenium generally works is that Selenium goes in through the back of the browser, says run this code for me, and executes it. It doesn't do it through the front of the browser, and by the front of the browser I mean through the document. So the document is your general web page, and the real reason that the document tends to have its own way of thinking is that you never want documents to be able to speak to each other for security reasons. If we look at iframes, for example, an iframe needs to be able to interact with the document inside it. But if I injected a malicious iframe into a page, you don't want those two things to interact with each other. And now, because you know it's the front end. There's an interesting thing when it also comes to firing events, because through the front of the browser, I can fire an event, but I'm doing it from a insecure place. So everything in the document is generally not trusted because, as I said, documents should never be able to speak to each other. If they share information, generally it should be able to come from the same domain or same origin. Let me rephrase that. It should always come from the same origin. And the same origin means that it's coming not only from the same domain, so example.com, but it's also coming from like the same, like is it a secure location or not? So is it HTTP versus HTTPS? One of the key things when I always tell people, like when you're evaluating frameworks, is like, can you go from an HTTP test into an HTTPS test flawlessly? And because if you can or can't, that should be the driving thing for you. And I know that there are frameworks out there, really popular frameworks, that allow us to do what they want, but they can't handle the scenario, right? And they also cannot handle the clicks properly. And the click here is that when it's doing a fire event, it doesn't have the ability to say if it's a trusted event or not trusted. So we know, like from a trusted event, that a real user has done this. Doesn't mean that automation should be blocking that ability. It's just that you need to know where to come in from. So tools like Selenium and Playwright, or anything that's kind of based off WebDriver specification and Playwright. Playwright's different. They're going in through the back. The minute they go in through the back, they're in a secure state. The browser knows that what state it is in. It knows it's under automation from the start, and it will allow you to drive what you need. And this is where we get this kind of 1 + 1 = 3, is that not every click is equal. If I do a general click, you, me, on a page, there's a field that gets added to the page, to the event. It's called is trusted. If trusted is true, then it is seen as a real event. If it is false, it is seen as a synthetic event that has been generated on the page, and we know that we don't trust anything that is generated on the page. It's just the way it is. This is important if you're using kind of like banking, iframes, third-party authentication like Okta and things like that, where they will be checking to see that there is a real user involved in the process, because if they see the synthetic event, then they know that they don't trust it. If they don't trust it, they don't want to be allowing people to use that browser. So it becomes really, really important that we have these kind of basic things going on. That means if your test is running in a web page, in an Electron app, you've removed enough of the tools around you that you suddenly start to lose trust in is the tool doing the right thing. It might have really nice fancy features, everything else, but if you can't be doing basic trusted events, then you're probably not testing the thing that you're expecting to test. Now, sometimes that's okay if you're just doing a basic component, a web component, but if you're doing an end-to-end flow and it needs to go through iframes and stuff like that, it becomes really, really frustrating that if you're not doing the right thing. It seems like my camera is deciding to die today, which is awesome. Cool. Let's start it up again. Cool. So I've gone through at a high level why this matters. The key takeaway that I hope you have while working this is that if you're not testing where your users are, you're already starting from a place where you're not fully understanding what people are doing or how they're doing it. And you might be getting a lot of tests passing when they shouldn't be passing in the first place. And that's really important, that you kind of have that confidence in your code, right? Tests generally should be giving you confidence in your product and things like that. And if you're starting from a place of not having it do what a real user's doing, then you're not necessarily getting the right confidence in the right place. So confidence is incredibly key to whatever we build, especially as we move forward. So this leads me on to my kind of the next point of testing where your users are. I've never been a huge fan of headless testing. I've said it for years that as I said earlier, I want you to be testing where your users are. Your users are not using headless testing. And I think it was Richard Bradshaw, while he was at Ministry of Test, he kept repeating, like, your users are never going to understand or be able to use your headless browser. So why? And the way headless browsing tends to work is that it should, in all honesty, be creating a scenario where the document is there, but you don't see it. And the idea is that, like, for years, Selenium, when you ran the tests, would tell the operating system, by the way, when this window opens, it must have focus. And the reason why it must have focus is that when I fire events through the backend, that the events are seen as trusted. So you're like, okay. And then the wonderful folks at Chromium, they thought, oh, actually, for testing, that kind of sucks. And truthfully, it does suck. You want to be able to create this scenario where you're able to work while your tests are running. If you're running Selenium tests, definitely 10 plus years ago, you wouldn't be able to run them sequentially or kind of have them running, because the minute they're running, you can't see the code, you can't see anything. You have to wait for your kind of everything to calm down or just stop, like if you've got a debug point, which was frustrating. And we definitely don't want that frustration, right? And so the Chromium folks went and built it. Because the Chromium folks went and built it, Mozilla went and built it. And the way that Mozilla built it is that it decided, like, it wanted to give people that confidence in the code. And whenever you started up a headless browser, it would create the window, but then it would give it you wouldn't be able to see it. Right, the window was there, but because you couldn't see it, you can interact with it. It wasn't being drawn onto the page. The Chromium folks had a very different way of doing it. And so it wasn't until Matthias Byans, who's an engineering manager at Google, he works on the DevTools team. He runs the WebDriver and Puppeteer teams. When he was there, he realized that actually Headless wasn't using Chrome. It wasn't using Blink. Blink is the rendering engine in Google Chrome, or in the Chromium browser. So what were you using? And it turns out when they looked into it, it didn't use any of the rendering, any of the way that, like, the browser generally works to everyday users. And so they had to go and rebuild how headless browsers work in the Chromium team. And because of that, suddenly they were like, oh, we've got to build this out. Right? We already know that, like, we've got these weird and wonderful bugs that are happening, like if you're testing in an Electron app versus Chromium, because like the way it would load a page. But yeah, it didn't share any code. And so Matthias, when he took over Puppeteer after the then Puppeteer team left to go work at Microsoft on Playwright, he went in and fixed it and made it realistic for what end users wanted. And I found that mind-blowing. Like, I always had my suspicions while I was working because there were a few things that just didn't add up. But it was nice to see the reality of it. And it's important. Matthias has now gone on to, which I'll kind of go to in a minute, he's gone on to create the Chrome for testing product at Google, which allows you to build and test your software using a kind of stable version of Chrome. And so, yeah, we've come to realize that headless and headful is not necessarily the same, right? It is literally apples to oranges. In the same way, if people go compare Selenium with Playwright, the thing that they care about in Selenium and Playwright are not comparable. They are literally apples to oranges or apples to lemons. And so when we are building these things out, we need to be more realistic and understand that some of these things are different, and different is fine, right? But at least we need to know that where the differences are. And once we know where the differences are, we can make informed decisions, right? Headless browsing definitely improves productivity because you can still carry on things while your tests are running. Like you can have a look through code or whatever, compared to headful. So this leads me nicely onto kind of the next part of the topic, where we've talked about like the events that are happening, and those can be different depending on where you run them and how you run them. We've talked about headful and headless being different things, but what about like real browsers versus browser engines? Now, some tools like to ship Chromium and allow you to use that with your testing. And that can be okay. And then other browsers, like if you're using Selenium Manager, Selenium Manager's been out for a couple of years now. Selenium Manager will set up the real browsers for you where possible, because that's where Selenium's opinion lies, is that use what users are using. And part of why I tend to kind of tell people to not use Chromium is that if you look at like this slide on the screen here, we have Vivaldi, Opera, Brave, Edge, Google Chrome, and I forgot the last one. If you go speak to any of those companies, they will go, well, you know, for the most part, the rendering engine's the same. We kind of use all the different same parts in V8, which is the JavaScript engine. But then we've made our changes, right? I've seen it numerous times on social media where Brendan Eich, so he was the creator of JavaScript. He's now the CEO of Brave after he left Mozilla. Getting annoyed when people say, well, why use Brave when you could just use Chrome? And the differences tend to be kind of small, but incredibly impactful. Incredibly impactful. And I want to kind of really stress that. And the same can be said for kind of Safari, with all its different versions versus WebKit. The changes that are different between them can be incredibly impactful. And I'm going to go into that in a moment. But I'll go back. So here, the way Brave handles third-party cookies is not the same way that Edge and Google Chrome do it. The Opera folks will say that they've tweaked some of the code to improve, especially because of Opera GX. They've tweaked the code to allow it to enhance certain features like GPU usage, things like that, even though the underlying technology is all the same. But when we look at like the third-party cookies, for example, if we're importing cookies and things like that, the cookie store could allow you to have your sessions. Based on your sessions, you know what people have seen or things like that. And if there are these fundamental differences with cookies and sessions, that means the way people log in, log out, all of that suddenly changes depending on the browser. So, and as I said, Brendan and I will get annoyed with you if you go, but Brave's just like Chrome, so why use Brave in the first place? Because their Brave's whole mantra is like, well, you don't need all the advertising. You don't need all of that. And if you're having all that advertising, it has a knock-on effect to how the rest of the browser, the page will load. And then from there, you can have other interesting problems suddenly occurring on your website and how your users interact with it, depending on these things. Now, my advice when looking at this is like, if you know everyone's using Chrome and you're getting like 0.1% of your traffic from Brave, at that point, like little bugs might not really matter if it's a Brave only bug. And the chances of it being a Brave only bug versus being Brave versus Firefox bug tend to trend downwards because there are some similarities, but then, as I say, the way the session storage, third cookies, and the cookie jar generally work, they're very different, and that difference can lead to interesting and wonderful bugs. And so, as I said, like Safari's got its different versions of Safari, Safari Tech Preview, and WebKit, and that can lead to other interesting bugs. So this one it's an old one, but it broke a lot of the web if you were using WebKit, and the bug only manifested in Safari on desktop. So like when you're testing on, like with Chrome, the way Chrome interacts with Linux could be different to the way Chrome interacts with Windows or Mac OS. Fortunately for the folks at Apple, Safari only works on Mac OS or iOS. And here the bug, which was IndexedDB stopped working due to kind of changes in the way the asynchronous code interacted with the browser. And so here, WebKit never had this bug. Interestingly, and I'll get into kind of the fun of mobile in a moment, iOS Safari did not have this bug, but desktop Safari did. So now suddenly we've got differences in kind of platform being like mobile versus desktop, browser engines versus the browser itself. And you've got these kind of like, because it is a huge matrix, you've got all these things moving around. You've got all these interesting bugs. And so if you were testing your login feature and your login feature didn't fail, but then when real users started doing it, it would have failed. If you didn't have useful telemetry around your front end, you might have not have noticed it until people started raising bugs. And sometimes people don't raise bugs, especially if it's if it's an e-commerce website, they'll just go to another vendor and go pick something else. And this was a simple break. Fortunately, I got fixed quite quickly. But if you were testing a WebKit, you would never have noticed it. Here's another example of WebKit. This is WebKit if you're using Playwright's version of WebKit and you want to do interesting things around Canvas. If you're using Safari, it works. If you're when I kind of took this is an older bug, but it kind of reinforces the point, is that the Playwright team didn't turn on this feature. So it's a config feature when you're compiling, and some of it's also around owning, paying royalties if you're doing video, for example. Video is another one where it can come up. Here, if you're doing WASM, you'd be using a lot of shared array buffer work. This works in WebKit. It works in Safari. It then didn't work in WebKit that was being shipped by Playwright. Right? There are equal and the same types of bugs like this. This is not me picking on Playwright. This is just showing examples. Right? There are equal bugs with Cypress, and because they were using the Playwright images, Cypress is now moving towards using WebDriver BiDi. They've already done half of it in Cypress 13, Cypress 14. I think we'll have them fully moved over to WebDriver BiDi. And so by moving to those things, because they're being worked on by browser vendors, you have all these other great benefits because they can kind of find these things. And the final thing on this before I move on to the next topic is that Chrome for testing was created because Matthias Byans, the engineering manager at Google, was getting frustrated that people were raising bugs around Puppeteer and things like that, around their automation. And whenever he and his team looked at the browser or kind of the SHA that people were saying, the bug didn't either exist or the SHA didn't exist in the Google Chrome space, and it took a lot of extra work. So this is why Chrome for testing now exists. It allows them to, like Selenium Manager, to allow you to have a fixed version of that browser, so you can always do it. It also gives them, when they're trying to debug and fix bugs in the browser, a fixed point that they know they can work from. SHAs that like the Playwright team use, or kind of anyone else who's shipping their own version of Chromium, don't always match up. And especially like if you're getting a bug in like Brave and it turns out to be a Blink bug, and then they go to Google Chrome, and it creates this thing where it becomes incredibly hard to work against. And then finally, we've got real mobile browsers versus simulated browsers. And I know that this one tends to elicit a lot of complaints from people because they go, mobile testing is hard and expensive. And I fully understand that. And the idea here is that at least if you have the tools to know what is going to be different, you can make informed decisions on whether you want to get mobile devices and use Appium for your testing, or if you can just shrink everything down and do it all Selenium on desktop. And so the main reason for this is that, like during COVID-19, we saw a boom in mobile usage across the globe. And I saw it while I was at Browser Stack as well. It became huge. Like people went from being, say, 70% desktop usage to like 80% of the usage now moving to mobile. But getting mobile devices is expensive. I've said that before. And mobile development is generally hard, right? You've got to connect, like you're kind of working through pipes to another computer and working that way, and it becomes hard. But DevTools has improved that over the years, and it continues to improve it. So it's not necessarily a huge problem. Yeah, and like I say, it's got hard, but not insurmountable. Now, resizing a desktop browser so that the window is the same size as a mobile browser is not the same thing as a mobile browser. Earlier, when I was talking about like WebKit not having a bug, but desktop Safari having a bug, but not on mobile, is that like in that scenario, Shrunk that browser would have had the same bug as desktop, but that didn't exist on mobile browsers. So again, you're now looking at a wider area that needs fixing, not necessarily just that one small area. The other thing is that if you've seen my talk a few years ago around like Selenium is visible or is shown or is displayed, is that way browsers render the page is they create these display lists. They give it to kind of the operating system, say, please display this, and the operating system will then clean up what needs to be shown and do it. Mobile has a different operating system to desktop. The way those display lists work is very different. The other thing is that mobile phones, not necessarily these days, but it's still not as good as, say, if you work on a really good computer, like laptop for building software, it's generally high powered. Your mobile device is not nearly as high powered, and the way it does rendering changes because it tries to optimize where the person is moving to, where they're doing things and things like that. And so it's it can be a bit much. So because of the way like the underlying operating system interacts with the browser on mobile is going to be different to desktop. Resizing to down means that you're using different code paths on desktop than you would be using on mobile. And here's an example, right? Again, I'm not picking on Playwright, but this is around device pixel ratio. And the way the ratio, like you can ask the browser, hey, what type of screen do you have? What do you do with this? DPR, device pixel ratio, is important because like if I have a low quality monitor versus my Mac screen, I'm going to get different device pixel ratios. And again on iOS. And if you're on iOS and you want to do something incredibly fine and you need high pixel ratios, you're not necessarily going to get that. And so Playwright here was going, well, when I'm in Headless and I shrink the browser, I'm going to give you all the wrong information. So like here is the epitome of everything all in one gone wrong. And you don't notice this until kind of you hit these weird and wonderful bugs, and then you spend days trying to fix it. And the problem could be like you're just not using the right thing. So finally, like I'm going to just talk on risk management. Hopefully with all of this that I've shared with you today, that you understand the tools, the way people work on it, the way browsers have at a high level work. There's a lot more intricacy. Browsers are incredibly complex. They're as complex as operating systems, which is why we have Chrome OS and Firefox OS. And so when you're doing this, you need to just understand the risk management, right? If you're doing a basic form, web form, you probably could shrink your desktop browser to be a mobile browser size and do it there. Where if you're it's less of an issue. Where if you're doing Canvas stuff, that would be big. So just like understanding the tools and then going from there, we could do amazing things. So just understanding the risks, knowing where the differences are between our browsers makes a huge difference. And so with that, hopefully you've stayed all the way to the end and you have some amazing questions. I will go into the questions and hopefully Pallavi can help me with that. Thank you.
Thank you so much, David. That was one very insightful talk, and some very interesting case studies to have a look at. And indeed, with all these various tools now available to solve the test automation problem, browser automation problem, it's good to know as an end user what the tools are actually offering us. Are we testing on the real browsers or on browser engines, and what are the risks if we are not doing that are there? So I think it's a very insightful and important talk for the community. Thank you very much for this. So we are now open to questions. If you have any questions, please post it up, and David is here for a few more minutes to answer them. So we had a question by a user called Cypress XP, where he basically wants to know that if we are going to continue supporting, it's an off-topic, page factory in the upcoming Selenium versions, as his project relies on it, as the project relies on it.
So I believe so. Like I think the only time where we've removed that stuff is in .NET, but that's been removed for years, and that was because Jim Evans made the decision at that point that it's a simple enough library to build yourself, and so he moved it into a separate repository, and it kind of exists there. I don't think we have any intentions of removing the code. The main area of focus for the Selenium project at the moment is updating everything to use WebDriver BiDi. Like that is our core thing that we're trying to fix at the moment. Because if we can fix that, it gives you a whole bunch of really nice APIs like network interception, things like that. So I don't see those things changing. And generally, when changes are made, especially breaking changes to Selenium, we're incredibly conservative. So like we made one change recently and we regretted it and rolled it back instantly. So hopefully, like, you know, we try to be understanding that we don't want to break people's tests just by upgrading our stuff.
Okay. I hope you got your answer. Thank you very much for answering that, David. Are there any more questions anyone would like to ask? Please post it up. So, David, meanwhile, people post questions. Would you like to tell us what we can expect from the Selenium 5, which is going to upcome? We had a Selenium 4.28 release today. So, would you like to just give the community a roadmap of about Selenium 5?
I think Selenium 5 at the moment, there's still a lot of things being discussed within the TLC. Where possible, we want to improve, like Selenium gives you the basics to do browser automation, right? And then you can build anything on top of it, which is why tools like WebDriver IO, Selenium base if you're a Python user, all of those things kind of allow you to use it and then build off, and they have their own weight library so on that. So it's improving that side. I think the key part is definitely the WebDriver BiDi stuff. Anything that we think that we can improve the what's the word I'm looking for? To give people more like batteries included. So
Yes.
allow you, instead of you having to download everything. So like
Mhm.
with Manager, that was our first real batteries included feature that we built into Selenium. That sets up all the browser, all the drivers, things like that. Things that people are going to be struggling with. We're going to be doing more of that.
Okay.
The key thing here is that we can only do so much as a volunteer group.
Right.
So people watching, we would love to have more collaborators helping from documentation to code. Like there is no small job that's kind of insignificant. All jobs are important and impactful for everyone.
Yeah, that's very well said. Jim Evans also spoke about the exact thing where Selenium 5 might also take the route of, be more batteries included in the first stock of the community. And indeed, Selenium Manager, which came with Selenium 4, was the first step where we said that the browser management now has becomes the part of Selenium. And so we have an upcoming conference of Selenium, which is happening in Valencia, Spain. We would request you guys go ahead and check the Selenium conference and APM conference page. Both the projects are gearing up and having the conference for the people. It starts from 26th March to 28th March, and the tickets are live right now. The agenda is set. So we would request if those interested, please do check out the Selenium conference and APM conference page and have a look at the upcoming conferences and meetups on Selenium. Are there any final thoughts, David, you would like to share?
Just the main one, like you were saying, Selenium conference is coming. Please, if you can, come to the conference. Please buy tickets. Come see it. There's some really good talks that I've seen on there. We've got amazing keynote speaker from Angie Jones. She's going to be there. Angie's always fun to watch and hear, and she's literally bigger than life. Like, an amazing human being, and like loud and funny and amazing. I'm going to be there. A lot of like all the PLC, the project leadership committee, is going to be there. Most of the TLC is going to be there. Most committers are going to be there. It's, for us, it's always been a fun time to spend with the community. So yeah, if you can make it out to Valencia, that would be amazing. It's a beautiful area, and I know they're kind of recovering from major floods, so it's nice to be able to kind of help them in one way or another, like just spending a bit of our money in that area to support. So yeah, like all support would be good. If not, hopefully you get to watch everything on YouTube and continue supporting the community where you can.
Yeah, that's excellent about Anyground community, David, that indeed, for any open source project to succeed, the community is the force behind it. So we would like to extend our thanks to the community of Selenium. It's been 2 decades of existence of Selenium, and we are looking forward for a few more decades. Thank you very much, David. Thank you so much for your time today. Thank you, everyone who joined us. We appreciate your presence. You can watch the talk later on YouTube. Thank you so much. Thank you, David. Bye.
Thank you, everyone, for joining, and thank you, Pallavi, for organizing it.
Thank you so much. Bye.